Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about exponents and division. We're going to simplify. Your answer should contain only positive exponents. So, if I was given this problem. Minute Math, when you need help you use Minute Math. 5 to the 4th power over 5. Well, one thing we know is that this 5 down in the denominator, that is to the 1st power. And one of our rules with exponents is for dividing terms that have the same base, which we have, 5's here, we subtract the exponents. So we have 4 and a 1, so we have 5 to the 4 minus 1 power. 4 minus 1 is 3, and so our final answer is just 5 cubed. 3 over 3 to the 3rd power. Well, we know the first 3 in the numerator, that's 3 to the 1st power when nothing's written. Now, our rules here are rules with bases, right? And then we're dividing. The bases are the same, okay? We look at the exponents, and we have to subtract the exponents if we're dividing where the base is the same. So we have 3 to the 1 power and 3 to the 3rd power. So when we divide that, that's 3 to the 1 minus 3 power, which is 3 to the negative 2 power. Well, we know a negative exponent is the same thing if we put it down in the denominator as a positive, and so we can write this to be 1 over 3 to the positive 2 power, and there is our final answer. 2 squared over 2 to the 3rd power. Well, since we have the same base here, okay, we have to subtract the exponents when we divide. So 2, same base, and then we take the exponents, 2 minus 3. Well, 2 minus 3 is a negative 1, so we have 2 to the negative 1 power. Now they told us our answer should only contain positive exponents, so we can write that in our denominator here. So we have 1 over 2 to the positive 1 power, right? But we don't need to write that positive 1 power, we can just leave it blank there. So it's just 1 over 2, and that is our final answer. 2 to the 4th over 2 squared. Okay. Well, first I want to take is, I have the same base here, okay? So when we have the same base, we want to take the exponents, and we're dividing it, and we subtract the exponents. So we have the 2 here, and we take the 4, and we subtract that 2 from it, the denominator's exponent. So now we have 2 to the 4 minus 2 power, which is simplified to be 2 squared, and there we have our final answer. 3r to the 3rd power over 2r. So what I want to do here, well, we first look at our variables. We have the same base in the numerator and the denominator, and we have the exponent of 3 in the numerator, okay? So this denominator one also has a 1 power up there, but it's not really written, so we just got to make sure we know that, all right? Well, 3 over 2, well, that can't simplify anymore, so we keep it as 3 over 2. Now when we divide with the same base, we subtract the exponents. So we have r to the 3 minus 1 power, and 3 minus 1 is 2. So my final answer is 3r squared over 2. 7k squared over 4k to the 3rd power. Well, we have the same base here, and when we divide with variables that have the same base, we have to subtract the exponents. So 7 over 4 stays there, okay? And then we have, well, k to the 2nd power minus, or divided by k to the 3rd, so that's k to the 2 minus 3 power, okay? 2 minus 3 is negative 1, so we have 7 over 4, and we have k to the negative 1 there. Now they told us we couldn't have any exponents that was negative, and so we needed a positive exponent. So k to the negative 1 power is the same thing as k to the positive 1 power, where the variables in the denominator. So we have 7 over 4k. This is the 1st power, but we can just leave it as a k, and there we have our final answer. 10p to the 4th power over 6p. Well, first thing I like to do is I look at the coefficient. I have 10 over 6. That fraction can simplify, and they both are divisible by 2, and so we can write this to be 5 thirds. All right. So now let's deal with the variable. Remember, that's being multiplied here. We have p to the 4th power divided by p. This p in the denominator is to the 1st power. Okay. Well, when we divide with the same base, we subtract the exponents. So we have p to the 4 minus 1. Well, 4 minus 1 is 3, and so my final answer here is just 5 thirds, right? And then in the numerator, 3 is positive, so we keep up there, p to the 3rd power, and there we have our final answer. 3b over 10b to the 3rd power. Okay? Well, first thing, I look at the coefficients. These coefficients cannot be simplified anymore. 3 divided by 10. So we're going to keep that for the rest of the problem. Look at the variables now. We have b here, and we know that's to the 1st power when it's not written for the exponent. And we have it's being divided by b to the 3rd power. Okay? Well, when we have the same base, we subtract the exponents when division is involved. So b to the 1 minus 3, we subtract the exponents. Well, 1 minus 3 is negative 2, so we have 3 over 10 times b to the negative 2 power. We know b to the negative 2 power is the same thing as 1 over b squared. We can combine all that together to get our final answer of 3 over 10b squared. 8m to the 3rd power over 10m to the 3rd power. Okay? Well, this one's kind of tricky, all right? Let's look at the coefficients. 8 divided by 10. Both are divisible by 2, so we can simplify that to be 4 fifths. Now we have m to the 3rd divided by m to the 3rd. We know anything divided by itself is always going to be 1. But let's show how this works. We have the same base, so we have to subtract the exponents. We have m to the 3 minus 3 power, and so that simplifies to be, well, 4 fifths m to the 0 power. We know anything to the 0 power is just 1. And so our final answer can be written just as 4 fifths. 7n to the 3rd power over 2n to the 5th power. Well, our coefficients are 7 over 2. That cannot be simplified, so we're going to keep that fraction for the rest of the problem. We have n to the 3rd power over n to the 5th power. Since the same base as the variable m, we take the exponents and we subtract them. So we have n to the 3 minus 5 power. Keep on going, simplify this. 7 halves times 3 minus 5 is negative 2, and we have times n to the negative 2 power. We know n to the negative 2 power is the same thing as 1 over n squared. Remember, we can only have positive exponents. Bring all that together for our final answer, 7 halves, or 7 over 2 times n squared. 2n squared over n. Well, the denominator here has 2 things that aren't written. Remember, there's multiplied by 1 down there, and we have n to the 1st power, right? One's not written. Just keep in mind. Well, as we keep going, we look at the coefficients, and 2 divided by 1 is still 2. Okay? Now look at the variables. We have the same base. Okay? When we have the same base and we're dividing it, we subtract the exponents. So we have n to the power of 2 minus 1. And we know that 2 minus 1 is 1. So we have 2 times n to the 1st power, which we could write as our final answer here. Don't really need the 1 exponent. 2n. And there we have it. 8x to the third power over 10x to the fifth power. Let's look at the coefficients here. 8 over 10. Okay? Well, 8 over 10, we can simplify that. Both are divisible by 2, and that becomes 4/5. Now let's look at the variables. We have x to the third power divided by x to the fifth power. When we divide variables with the same base, we subtract the exponents. So we have x to the power of 3 minus 5. Keep on going there. 4/5 still stays there. And x to the 3 minus 5 power, 3 minus 5 is a negative 2. They told us we cannot have negative exponents, so x to the negative 2 power is the same thing as 1 over x squared. And so we can combine all this together for a final answer of 4 over 5x squared. 12x to the third power over 9y to the 8th power. Let's first look at the coefficients. 12 divided by 9 can be simplified to be 4 over 3. We can divide both numbers by 3 to get that. Now, let's look at our variables. Well, this one's actually pretty simple. We have an x to the third power in the numerator and a y to the 8th power in the denominator. They are not like terms. We cannot simplify them anymore, and so our final answer is just 4x to the third power over 3y to the 8th power. 14x to the fourth power, y to the 7th power, over 6x to the 5th power, y to the 4th power. All right. Let's look at the coefficients. Well, we have 14 divided by 6. Both are divisible by 2. 14 divided by 2 is 7, and 6 divided by 2 is 3. Now we can divide our like terms. We have x to the 4th over x to the 5th. When we divide with the same base, we subtract the exponents. So we write 4 minus 5 here. Same thing with the y's. Y's are the same base. We're dividing. So we have y to the 7 minus 4 power. Keep simplifying. 7/3 stays there, and x to the 4 minus 5th power is x to the negative 1 power. Y to the 7 minus 4 power is y to the 3rd power. Okay? Well, we know we can't have any negative exponents. We need to have positive exponents. So x to the negative 1 power is the same thing as 1 over x to the 1st power, and we have really y to the 3rd power over 1. That means the same thing. Now it's all set up neat, and we can combine it all together for a final answer. 7y to the 3rd power over 3x. And there we have it. 11u to the 4th power over 17u to the 7th, v to the 9th power. Okay? Well, if we look at the coefficients, we have 11 over 17. That can't simplify anymore, so it's going to stay 11 over 17 for the rest of the problem. We then have u. We have u to the 4th power divided by u to the 7th power. We have the same base there, so we can divide it, and we just have to subtract the exponents. So that's u to the 4 minus 7 power. That's a u. Okay? Then we're multiplied by, well, v in the denominator is the only variable that's v, so it's 1 over v to the 9th power. Okay? Let's keep simplifying here. U to the 4 minus 7 is u to the, well, 4 minus 7 is minus 3. And we're still multiplied by 1 over v to the 9th power. U to the negative 3rd power, again, we have to have positive exponents. So it's 11 over 17 times 1 over u to the 3rd power. Remember, negative exponent in the numerator is positive in the denominator. That's times 1 over v to the 9th. Now we can bring all that together to write our final answer. That's 11 over 17 u to the 3rd, v to the 9th power. 4y to the 4th power over 14 y x to the 8th power. Okay? Well, what I want to do here first, okay, I see 4 over 14 are coefficients. I want to simplify this. Both are divisible by 2. So 4 over 14, the same thing as 2 over 7. Now let's deal with the variable y. We have y to the 4th power over y. Now, the denominator y is y to the 1st power there, and we divide variables that are the same, we subtract the exponents. So we have y to the 4 minus 1 power. Now the second thing, we have x to the 8th power in the denominator, and we can rewrite that to be 1 over x to the 8th. Okay, there's no other x to simplify with. So let's keep going, simplifying. We have 2 over 7 times, well, y to the 4 minus 1, that's y to the 3rd power. And then we still have the 1 over x to the 8th. Well, that y to the 3rd power is the same thing as really, right, over 1, y to the 3rd over 1. And so now we can combine everything for our final answer. We have 2y to the 3rd power over 7x to the 8th power. 12y x to the 4th power over 10y x to the 8th power. Okay? Well, what I want to do first here is I look at the coefficients and I want to simplify them. Okay? Now 12 over 10, both of those numbers are divisible by 2. 12 divided by 2 is 6, and 10 divided by 2 is 5. Now let's look at the variable y. We have y divided by y, and any number divided by itself is 1. So y divided by y becomes 1, and multiplied by 1 doesn't really do anything. It's what we call the multiplicative identity. Lastly, we have the variable x. We have x to the 4th power divided by x to the 8th power. We subtract the exponents, and that's x to the 4 minus 8 power. Let's keep simplifying here. 6/5. Don't worry about the multiplied by 1. Doesn't change anything. And x to the, well, 4 minus 8 is a negative 4 power. X to the negative 4 power is the same thing as saying 1 over x to the positive 4th power. Combine all that together to get our final answer. 6 over 5x to the 4th power. 18 x to the 8th, y to the 8th power, over 10x to the 3rd power. All right. So what I want to do, I'll look at the coefficients. 18 divided by 10. All right. Well, 18 divided by 10 can simplify. Both of these are divisible by 2, and 18 divided by 2 is a 9, and 10 divided by 2 is a 5. From there, we would need to simplify the variable x. So, x to the 8th power over x to the 3rd power. When we divide variables with the same base, we subtract the exponents. So, x to the 8 minus 3 power. Lastly, we have y to the 8th power. That's just by itself. There's nothing else that has the variable y. So we have y to the 8th, and that's being divided by 1. Well, let's go simplify. 9/5 here times x to the 8 minus 3 power. That's x to the 5th power. Now, that's the same thing as over 1 right there. And we have y to the 8th over 1. We can combine everything together to get our final answer. We have 9 x to the 5th, y to the 8th, over 5. And there we have it. 5 n to the 8th power over 20 n to the 8th power. All right. First thing, let's look at the coefficients here. 5 divided by 20. Well, both of those numbers are divisible by 5. 5 divided by 5 is 1, and 20 divided by 5 is 4. Now let's look at the variables. We have n to the 8th over n to the 8th power. So we know that every number divided by itself is going to be 1. Let's see how this works. We subtract the exponents when we have the same base. So we have n to the 8 minus 8 power. 1/4 still stands, and n to the 8 minus 8 is n to the 0 power. And we know any number to the 0 power is 1. So we have 1 over 4 times 1. So quickly and easily, my final answer is 1/4. 16 y x to the 4th power over 9 x to the 8th y squared. All right? So we first want to look at our coefficients here. Can we break that down? Can 16 and be divisible by 9 or simplified in any way? The answer is no. We have 16 over 9 here. Now let's look at our variables. So we can only divide our like variables. We have x to the 4th here and divided by x to the 8th. Be careful, I kind of crisscrossed there. Well, when we have the same base, we subtract the exponents. So we have x to the 4 minus 8 power. Remember, be careful here, okay? They're not lined up perfectly. And if you want to line it up beforehand, that might make it easier for yourself. Let's look at the variables now. Y. Remember, this y is y to the 1st power. So we have y divided by, or y to the 1st divided by y squared. And that's y to the power of 1 minus 2. Again, we subtract the exponents. Simplify. We have 16 over 9. And 4 minus 8 is negative 4. So we have times x to the negative 4 power. And y to the, 1 minus 2 is y to the negative 1 power. All right? Well, we know any exponent that's negative, right, is the same thing as positive in the denominator. And we need to have positive exponents. So again, 16 over 9 here. But now we have 1 over x to the 4th times 1 over y to the 1st power. We can combine that to write our final answer, 16 over 9 x to the 4th power times just y. And we don't, remember, we need to write that exponent of 1. And there we have it.
Minute Math. When you need help, you use Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.